So this is a common boost converter. Okay, so here I will show the condition during the turn off of this, sorry, the turn on of this switch. So when this switch will be turned on, this inductor will be charged. And similarly, when switch will be off, this inductor will discharge across this capacitor or and load. So you might wonder that it is connected through sources. So why would it discharge? Why not it will charge again? So if you see generally in boost converter, V naught is generally greater than Vs. Yeah. So that's the purpose of the name boost converter. It will boost the output voltage. So this voltage is always higher compared to this one. So again, the voltage will be negative. So minus V by L. So that slope will be di by dt will be minus because it will be Vs minus V naught by L. And since V naught is higher than Vs, so it will discharge. Now we will see some waveforms as well for continuous mode. So here it is when during uh, during the conduction of switch, it will be Vs, whatever the value that will appear among the inductor. So VL is equal to Vs when this switch is connected, okay, and VL will be Vs minus V naught when switch is off, okay. So hence this inductor will get charged and discharged. So you must be familiar with this, I guess. And after that, the important thing is how that diode and capacitor current will vary, right? So, if you observe the circuit carefully, you can see, let me bring back here. Uh, So, diode will conduct only when the switch will be off, right? So, from dt to t, this is the turn off period. Whatever the waveform of inductor, you see, the waveform of inductor, we just cut it from here and we just pasted it here. So, the same waveform after cutting, the value of diode current will be average of this waveform. If we find out the average value of this waveform, how will you find? You can easily divide it among two parts. Let me discriminate among themselves. So one is triangle, one is rectangle. So you can easily find the area of both by adding. And if you got the value of this ID, now the task is to find out IC. Okay. So IC is nothing but ID minus I note. Okay. So I note would be, somewhere here. Like let us see, since this value is protruding towards upward, so we will take this much. Let us consider. And if we reduce I note from this, then you will get, shifted version of this waveform, and this rectangular portion will come down, and earlier it was 0, so it will get shifted by the value I naught, and I naught is nothing but the V naught by R, and since it is in negative direction, so we are taking minus V naught by R, and the upper portion will be upward. So if you equate this delta Q and this delta Q, both the area will be same, should be same, okay, ideally. There are some cases where parasitic resistances will be connected here, or some coil resistance will be connected there, but that should not be our concern as of now. So now these both areas should be equal. So, if you need to find the ripple across the capacitor here, because you won't get, flat voltage waveform, right? You won't get this kind of waveform. you will get some ripple kind of voltage waveform. So what will be the value of this delta V naught? That you can derive from this graph. That will be delta Q by C. So again, if you increase the value of capacitance, your ripple will get reduced. Okay. So this is a typical waveform of capacitor current, and based on this waveform, you can easily calculate the ripple value. We will solve some problems where we can calculate those values from the graphs. So basically, two things are important here because in buck converter, our load was directly connected to inductor, so we need not worry about that. But here we need to worry because you need to identify diode current, and that average value of diode current is your load current. So sometimes you need to find RMS value of diode current. Sometimes you need to find average value of diode current. So just for the sake of completeness, we will take here what will be the average value of diode current in terms of inductor current. Okay. Can anybody let me know which factor should I multiply it here so that it will be equated? So how do you find average value of diode current? Because see, inductor current will flow across this diode when this switch will be off, right? So when this switch will be off, switch will be off for this period 1 minus d into time period, right? And if we divide by total time period, so that will be your average, right? Am I correct here?
Yes, sir.
Yeah, thanks. So effectively, it will nothing but IL1 minus D. Similarly, if you need to find the RMS value of ID, again, you take the current or instantaneous value of whatever the current will flow across the device, and you just take a square root, and again the period for which it is flowing, that is 1 minus d into t divided by t. So you can easily compute your RMS IL into 1 minus d. So this kind of things you should be well versed with. It should be very handy because anytime if you forget some formulae or something, you need to go to the basic straight away and you need to derive it from there. Okay, so that was regarding this. So yeah, this was regarding continuous conduction mode. Okay, we were discussing about CCM. Now to see about DCM, I hope this should be clear to you. If any doubt is there, please feel free to ask. Okay, if not, then I will move ahead and I will see DCM. Okay, so this is again a typical waveform where we clearly observe that your inductor current is getting discontinuous, right? Because it is not conducting for some period out of a time period, right? So some charging instance again and some discharging instance. Again, your V naught average will be higher in DCM mode compared to V naught average in case of CCM, right? As I mentioned in last lecture also, since your negative portion is less, you will get more value of V naught. Uh, you should try to find out the area and all so that by this one, 0 to T 1 by L VLDT, you equate it to 0, and you try to find out for both the cases, you will observe this significant observation. So again, now focus about ID. So ID will conduct when your inductor will be discharged across the load, right? So your inductor is getting discharged across the load. However, no rectangular portion is available in this portion, right? Here some rectangular portion was there in earlier case of CCM, but now in DCM we do not have any rectangular portion because your inductor current itself is just starting from zero value. Earlier the case was, let me bring back that graph and place beside. So you can see your inductor was getting started. So your diode current had some rectangular portion and some triangular portions. Now it is only triangular portion, and it is what is called ripple current across the inductor, which is also available here, delta IL. And delta IL is nothing but the IL max or I max. Okay. I hope it is fine till now. And now I will equate. So again, for DCM, we will go with basics. We will equate with this integration, right? So we can ignore L because it will anyway become 0 after multiplying. So from 0 to dt for this dt period, 0 to dt, the value is Vs, right? Plus for d1t period, for dt to d1t period, right? Your value is Vs minus V naught into dt equal to 0. So now we just need to solve this equation, Vs into dt plus Vs minus V naught d1 minus d into t is equal to 0. So after you solve this, you will get equation d plus d1 by d, right? So this is sort of we call transfer function as well, because output by input, uh, generally known as transfer function. So your this value d plus d1 by d1 should be generally greater than 1, or generally what? Regularly it will be greater than 1. And earlier, when CCM case was there, so D1 for CCM, D1 was 1 minus D. So if you put it here 1 minus D, you will get D1. I am putting 1 minus D, 1 minus D. You will get 1 by 1 minus D. So, you can say CCM is just a special condition for DCM, and vice versa is also true for some specific circuits. So, we derived this. You should, I guess you should remember it, or you can easily derive it, right? It is one step, just it is one step process. You just equate your voltage and you will get it. So after what? After this, we will need to derive this D1 in context of known terms, right? We know D, Vs, V naught, F, L, R, and all. Basically, D1 should be known to us because D1 would not be generally given, and we should know this value of D1. So now we will move towards deriving. And when we are deriving D1, and we know D1 is the period when our inductor is getting discharged. So this is the period of D1. Let me zoom it. So this is period of D1 where we are talking about. So we must talk related to diode current, okay, and this ripple current, right? So we will do the same. We will equate both our diode current in terms of ripple current. So I will write ID is equal to ID average, right? ID average will be, I told you, ID average will be what? ID average will be IL into 1 minus T. Or here we are dealing in terms of D1, so IL into D1, right? Now, the average value of IL would be half into del IL, okay? Half into del IL into D plus D1 into D1. I can write in this manner anytime. Or let me bring back that graph. So this was our graph for DCM. We know, right? If we need to equate ID, this ID average, we need to know this del IL. And if we know this del IL value, we can easily calculate this portion or this area, right? So if you do that, del IL is nothing but the, sorry, uh, we will take some particular value here as we are moving across, sorry, it was correct. Um, yeah, this was the value earlier. Now we can write del IL as Imax because del IL and Imax both values are same. So further, I will simplify. You know the value of ripple. If you don't know, do not bother. You can easily equate, L del IL by dt, L del IL by dt. And since I have mentioned dt, then we are talking in terms of on condition. And during on condition, our voltage was Vs, right? So you can anytime find out the ripple across inductor current. That would be Vs into D by F into L. You know, if you take T in terms of frequency, because generally you will be given with frequency. So this will be your expression of del IL, and this value will hold true for Imax as well. Okay. Now we need to equate, since ID average is also I naught average, all the value of current, whatever is flowing across the diode, that will be same across the load. So after equating it, I naught is nothing but your V naught by R. Okay. And del IL we computed in terms of Vs, T Vs by FL. Okay. And another term was half into D plus D1 into D1. So after you equate this, you will again get some value. So I will just write the final value. You can derive it from here so that we can focus more on problem side. So it will be more clear. So this is just again the same steps we are following. We are just equating your ID average equal to I naught, and you will get the value of d1 in terms of d, but this time with respect of v naught by vs. Why in terms of v naught by vs? That I will explain here. Because if you do not want this v naught by vs, then your equation will go in third order, third degree kind of equation. So you do not want to spend time in third degree equation. So for that purpose, v naught by vs, generally it will be there. If it is not there, and if you have calculated d1, you can anytime write v naught by vs is equal to d plus d1 by d1, I guess. D plus d1 by d1, yeah. So anytime you know this, either you will be given v naught by vs or you will be given d and d1. So you can easily simplify from that point. So finally, I am writing the expression for d1, and that is nothing but your v naught by vs and 2l by r into d into t. So again, v naught by vs, 2fl by r into d. So this is your expression of d1 in terms of d and some other known parameters. Again, it will depend on f, l, r, and of course d. So here the value of l and f, if you increase, your d1 will increase, and simultaneously your d value will also get increased, because if you can easily write it here, d1 is equal to v naught by vs into 2fl by r. Okay, any doubt in this portion? Sorry, I couldn't get you.
It's fine, sir.
Fine, okay, thanks, fine. So this expression, I think you should keep in your mind, or you can derive it at any time. Now moving towards some problems. So I will write some data and we will find some values, or we need to identify its conduction mode or its values. So let us take first, I will bring back the circuit so that we will not be distracted from the circuit. So this is the circuit here. And here Vs is 24 volt. L inductor is given 200 microhenry. Resistor value is 20 ohm. Capacitance is 1 millifarad. And switching frequency is 10 kilohertz. And duty ratio of this switch is also given, that is 0.4. Okay. So first thing first, we need to find, or we need to identify whether this circuit is in continuous conduction mode or discontinuous conduction. Okay. We need to find it. Okay. So from this expression of d1, we can easily find out, but one hurdle is there. We do not know the value of v naught. Okay. V naught is present in the expression of d1, and v naught is not given in the problem, and you cannot directly apply the formula of v naught by vs is equal to 1 minus d, because this formula is only valid for continuous conduction mode.
Yes, sir.
Or you cannot apply this formula also, d1 plus d by d1. Why? Because d1 is not given, right? So in that scenario, what will you do? Any approach do you have in your mind? Anyone? Any approach? What will you do? You have derived everything. You have derived even, you have seen all the continuous conduction mode and discontinuous conduction mode. So what will you do in that case? Okay, so the basic approach should be to identify about uh, your the basic thing should be your inductor current, right? When inductor current is starting from zero, then it is obviously it is discontinuous. Or if ripple current del IL is higher than your peak value of inductor current, then it would be in discontinuous conduction. So I think I have given the wrong values here. Sorry for that. I will immediately rectify these values. Otherwise, this problem will be messed up. 20 volt, D is zero point 0.6, frequency is 15 kilohertz, capacitance is 100 microfarad, resistance is 50 ohm, and inductance is 100 microfarad. Yeah, sorry about that. I took the same data as of last lecture of buck converter. So now, yeah, so we were discussing if delta IL is greater than IL maximum value, then of course y- your converter is operating in DCM mode. Let me
Why?
bring, why I am explaining that part, why it is so. Let me take that waveforms. Yeah. So you see, uh, if this value delta IL or IL minimum, sorry, yeah. So if this portion is greater than IL max, means your overall value IL max is what? Sorry, delta IL is what? IL max minus IL min by 2, right? If you equate it, IL max by 2 is greater than IL max minus IL min by 2. So indirectly, what you are doing, you are doing, okay, so what I mean to say here, if IL min is less than 0, if you compute the value of IL min, and that would nothing but IL average minus del IL by 2, right? IL mean would be IL average minus del IL by 2. If your IL average is this much and this portion is del IL by 2, and if you do it, and if you find that your inductor current is less than 0, so in other terms, if your inductor current, minimum value of inductor current is less than 0, it means your ripple is higher than whatever your IL max. Let's take this portion. Let's take your value is coming around here. This is your IL mean, right? Now, your ripple current value is what? However, it is not true in practical circuits. Just for the hypothesis, this ripple current will be that much. Are you able to visualize this waveform, or is it too messy here? Asif, you asked that question.
Yes, sir.
Are you able to visualize this waveform, or is it messy? Should I draw somewhere else? This portion. Okay, so just let me do it again.
Yes, sir.
Huh. So
So
let us
that
sup
has, yes,
not visible. Sorry, I will take some other color. So what I was trying to convey, if your IL minimum is coming somewhere here, you know, zero, below zero. Yeah. Now you tell me your del IL value will be higher than your I max or not,
yes, sir.
obviously. So either you equate del IL is greater than IL max, or indirectly you are telling that minimum value of your inductor current is less than zero. Both statements are correlated. So that's what we will do here. Since we did not had any other way to find out, because we were not given with the value of V naught or D1, so we had to go through very basic way, and that we will do it here. So we will equate IL minimum. So IL mean value is IL average minus del IL by 2. Okay. Now, IL average we need to find out. Again, I will take the parameter in front. So these are the parameters. See whatever the values we are given with, we just need to calculate with these much values. IL average is your, we can write IL average in terms of IS also, ID also, or I naught also. Since I naught is not given, so we need to move towards Vs. We need to find IL in such manner we could be able to identify the value of IL with the help of Vs, D, F, L, and R. Okay. So if you do this manipulations of equations, you will get IL average. First thing first, IL average is equal to IS average, right? Because inductor is connected directly to source. Should I bring back the circuit also? Uh, Yeah. So this way the circuit, which parameters were given. So IL average would nothing else but IS average, because all source current will flow through the inductor. Now we just need to find the value of IS. Okay. So if you do your power balance, someone want to say something? IS is equal to V naught I naught by Vs. I think someone mic is on. Okay, I have to mute him. Huh. We found Is in terms of V naught I naught by Vs. Okay. Now we do not know V naught. We can write V naught in terms of Vs. V naught by Vs is equal to 1 by D. Since we are taking or we are assuming it here in continuous conduction mode, right? Why we are taking now, as of now, continuous conduction mode? Because if we consider continuous conduction mode and if we prove it wrong, then it is in discontinuous conduction mode. So we are applying reverse engineering kind of approach. So V naught by Vs is 1 minus D into I naught. and I naught will be again V naught by R, and V naught is again Vs by 1 minus D. It will become Vs by 1 minus D whole square into 1 by R. So now Vs is also given, D is also given, R is also given. Fine. Now we started from IL mean value. So IL average we got. Now we need to find out del IL. So again, we know that del IL is nothing but your Vs into L, Vs into F by L. So IS average or IL average we found. Now del IL, if we want to calculate any time, you just do L del IL by dt into is equal to that value. So when the switch is on, VL is equal to Vs, you will get del IL dVs by FL. Again, this value may be in CCM or in DCM, we don't know as of now. So we calculated both the value. Now, our point was to find out IL mean, that was IL average minus del IL by 2. Now we put the value of IL average. So IL average we calculated Vs by 1 minus D square into 1 by R minus dVs by 2FL. This 2 term is coming from this equation. Now we just need to put all the values, whatever we are given with. So I will take it again here. You can also do by 1 minus 0.6 whole square into 1 by 50 minus 0.6 into 20 divided by 2 into 15 10 raised to power 3 to 100 to 10 raised to power minus 4. So if you equate this, what value you will get? You will get minus 1.5 ampere. This much value you will get after equating this much or doing such manipulations. You will get minus 1.5 ampere. Now it is very clear, your inductor current can't go in negative direction, right? Inductor won't allow that. The circuit conditions are not such that it will allow the flow of current along negative direction. So you, or we can interpret that this converter is in DCM, right? Is this part fine? If you are not given with any other information, then you just need to go with the basics, and you need to find out if your minimum value of inductor current is less than 0. In other terms, if the ripple value of your inductor current is higher than the maximum value of inductor current, then your converter is operating in DCM mode. So is it justified, Asif?
Yes, sir.
Fine. So now we are moving towards the second part. Okay? So earlier we found the value of D1 in context of known parameters. However, we did not derive that V naught by Vs. Okay. So let me write it again. D1 to D1 was nothing but V naught by Vs into 2FL by R into D. Okay. Now you can write d1 in terms of v naught by vs, or you can write v naught by vs in terms of d1. But let me tell you one thing. If you write v naught by vs in terms of d1, your equation will be a bit complex. So generally people, what they do, they write d1 in terms of v naught by vs. Okay, and they try to find out this ratio in terms of d and other parameters, other known parameters. So further, if you do this, d1 in terms of v naught by vs, so what you will get, if you remember, we had applied or we had equated id average to you know I naught. So now id average was nothing but half into vs into nothing, just half into del il into d1 into d1. This is nothing but your del il dvsfl, fine, into d1, because your diode is conducting only for d1 and you equated with v naught by r. Okay, and again I am writing d1 in terms of v naught by vs, so I will put d1 as v naught by vs into 2l by r df. Okay, so if you do that, you will get an equation v naught by vs whole square minus v naught by vs. Now we are eliminating that term d1 and we are bringing the term v naught by vs, which is important for us, which we want to derive, minus d square rt by 2l. If you equate this quadratic equation to 0, now you will get v naught by vs some values. Okay, that would nothing but you know minus minus plus 1 plus square minus b plus d under root d, under root was b square minus 4ac, 4 into a into c, so 4 into d square into rt by 2l by 2. Sorry, fine. So this 2 and 2 will be cancelled. So finally you will be left with 1 plus under root 1 plus 2d square rt by L whole divided by 2. So this is your transfer function of V naught by Vs in terms of or only for discontinuous conduction mode. If it would have been continuous conduction mode, it would be simply 1 by 1 minus d. Okay. Now your d1 term is eliminated. You can see from this equation, and this equation also you can keep it in your mind. Okay.
Yes, sir.
Okay, thanks. So now we will see. So yeah, so our question was to identify the value of output voltage. So now I guess you can right? Since you have the formula. Generally, I am not in the favor of, you know, cramming up the formula, but sometimes you need to do that because in exam it is not possible to remember everything. Generally, I am against it, but I am now recommending that for some scenarios you need to remember. Generally, I try to simplify all the things with the help of switching function, but here I can't do much. So you need to remember it. Our values was something like this. So now we need to find out the V note. So V note you can easily find. Right? I am not solving it here because it is very straightforward, you know. It will just consume time, so we will utilize that. So
Yes, sir.
you can find it on yourself. So you will get 60 volt. You just verify it. And yeah, you can see that Daniel Hart book. There also you will get the same problem. So it is nothing. I am making something. It is already given. I am just simplifying the concept here. And again, you will get the maximum. You will be asked in third part the maximum value of inductor current. So again, that will be del IL, and we have already derived that is dVs by Fl. You know, sometimes after deriving, lot of times get you will remember all the values sometimes. After you do lot of practices, if you solve lot of questions, you will easily remember. You will easily remember that del IL is dVs by Fl. That's how I got remember. I do not need to remember this value by the way, but it is remembered. So if you put all the value D, Vs, Fl, you will get your Imax and that will be 8 ampere. I'm just simplifying it here. So uh, I think this is all about your discontinuous conduction mode of boost converter. Just one more formula added. So if you simplify, if you know, you just need to remember one formula for buck converter, one formula for boost converter, and maybe one more formula for buck boost converter. In next session we will derive. So you just keep in mind this formula so that it will be very easy to verify the question whether it is in DCM or CCM. As in last lecture we also saw for buck converter, right? You remember that for buck converter? Anyone? That was V naught by Vs is equal to, you know, 2D by D plus D square plus 8L by RT, something like that. This this was for buck and this is for boost. So I hope this is all for this session. If you have any doubts, you can ask or you can mail me also. I got one doubt last time. Nokirti asked that, did you get that, Nokirti, or should I explain that?
Yes, sir, I understood the diagram that you have said.
Okay, so do I need to explain that? Should I open that?
So next session because time is going to up.
Yeah, anyone else?
Sir,
Okay.
please upload this video on your YouTube channel, sir.
Oh, acha, acha, sure, sure. I will upload that. Thanks for reminding. Yeah. Any other question?
No, sir.
Okay, thanks. So I think we should wind it.
Okay. Thank you, sir.
Yeah, thank you.
Thank you, sir.
Thank you.